All right, next problem up. First thing we do, question sentence. What do we want? So what we want is right here. What is the radius of the bin? All right, I'm going to tag that immediately. I see that very specific word for geometry and more specifically circles and cylinders. And so what we want is that radius. Let's go ahead and write that down. And then we'll continue from there. So here it says, a cylindrical grain bin has a height of 12 feet and a volume of 432 pi cubic feet. So look at what we're given here. We're given the shape, a cylindrical grain bin, and then we're given the height of 12 feet and a volume of 432 pi cubic feet. When I take this all in together, volume, cylinder, height, hey, we got to pop that formula up in our head immediately. And that volume formula is pi times the radius squared. This is the most important part, the square part, multiplied by our height. Now that we're here, just like with many problems, what we must do is plug things into the right places, then we'll move to calculating. So first up, my volume, I'm going to replace it with the 432 pi. And then on the right side, pi stays as is. The radius is what we're looking for, so I'll just go ahead and leave that as r. Write the squared, and then we'll replace the height right here with 12 feet. Okay, now that we're here, there's one thing that I want to point out that is going to make things just a little bit easier, and it's this. Everybody, if we take a look and we say, something along the lines of, hey, 2x is equal to 2 times 8. Everyone, if I were to divide 2 out on the left, isn't it true that since there's a 2 on the other side as well, that both sides will have cancellations? Is that true? If we're dividing a 2 out of both sides, and both sides already have a 2, yeah, they absolutely will cancel out on both sides. So why did I show you that on the right side over there? To show you this over here in real time. If I go ahead and divide out the pi from both sides, guess what happens? It's not a problem anymore. It goes away. So bam, goodbye over there, and now all we have is 432 equals r squared multiplied by 12. So my next move, I'm going to continue immediately to get that r squared by itself, so I'll divide by 12. Once I do that, I'm going to move to erase and make some space here on the right, and I'll divide 432 by 12. Once I do that, 12 goes into 43 3 times, because that's 36, leaving us with 7 left over. Drop that 2, and now we're going to ask how many times 12 goes into 72. 12 goes into 72, that's going to be 6 times. 12 times 6 is 72, so there we go, that's 36. Clean division, no remainder. And now what we have, again, cancellation, and that's going to be 36 equals r squared. That does not mean that the answer is A. That is not correct. The reason is we are looking at the value of r squared, not r by itself. So to get r by itself, here's what we have to do. We have to work backwards from squaring. Remember that squaring means this number multiplied by itself gives us 36. So I'll ask you, my party people, what number multiplied by itself gives us 36? Yeah, that's going to be 6. Nice and easy. And so there we are. 6 is that answer. After we square root both sides is essentially what we're doing. But that's the opposite of squaring. But nonetheless, we're good. 6 feet is the answer. And that's why answer choice B is correct. All right, next question here, my party people. Here we are. First things first, no matter what, we want to read the question sentence first. So when we do that, we see that the question sentence reads, how far did the cyclist travel in total? So everyone, before we even get started, although it doesn't say specifically the term that we're looking for, what does how far mean in this case? What do you think of? What kind of a unit do you think of? Yeah, if you're thinking of distance, absolutely correct. And you can support that with the answer choices. We see miles, miles all the way through. So yeah, for sure. We can really begin the problem by just understanding we want to find the distance for the cyclist. And then it says in total, which kind of raises my eyebrow because it might not be a super simple distance, rate, time. We might have to do something else. So let's understand what that might be. Because if I read through the story and not the numbers, just the story, follow along, we see that we have a cyclist that rides uphill, some details, then downhill. Okay, so everybody, when we think of that, we have two legs of a trip. We have the uphill part and then the downhill part. And if we want to get the total distance, well, guess what? We're just going to figure out what the uphill distance was. We'll add that with the downhill distance and we'll be done. So let's understand the information that we're given, because how do we get distance again? We definitely need to remember our formula. Distance equals rate times time. And let me ask you this, everybody. If we're talking about the uphill portion, what is the rate and what is the time that we're given? If we check out the uphill part right there, what do we see? We see that we have 2.5 hours right here, and we have 10 miles an hour there. So with those two things, guess what? We have everything we need for this first part. We have the rate, 10 miles an hour. We have the time, 2.5 hours. And so let's write that down. Distance equals 10 multiplied by 2.5. Now, before we get back to this, let's look at the downhill portion, because I really want to make a habit of setting up my calculations before I actually do them. That way we don't stress about numbers until it's time to actually calculate. So right over here in green, here's the downhill part. We have this amount of time and this rate. So same thing, we'll set it up. Distance equals rate times time, so 18 multiplied by 1.5. Now we're good. But everybody, let's remind ourselves, what are we going to do once we figure out each individual distance? Once we get each individual distance, we remind ourselves that, we are going to add. The reason that we're not going to subtract is because we're not looking for our final position. We are looking for the total distance, because we went uphill, then back down, but it doesn't matter. We just want the total distance, not where we end up relative to the start point. So if you have that question, hopefully that's a good answer. So let's go ahead and calculate now and get done with this problem. So the distance here, 10 multiplied by anything. The cool thing about multiplying by 10 is that you just move that decimal place over one time. So 2.5 times 10 is 25 miles. Now don't jump the gun here, because that's not going to be answer choice B. We are going to continue here. We have distance equals 18 multiplied by 1.5. Let's go ahead and do that right over here. And when we multiply by a decimal, we're going to go ahead and ignore that decimal and then bring that decimal back at the end. So here we are. We have 8 times 5, which will be 40. Carry the 4. 1 times 5 is 5. Carry the 4 is 9. Next up, we'll just drop a 0 so we can start off right where we are with the 1. 8 times 1. 1 times 1. We add that together, and that looks like 270. But remember, we're bringing one decimal back. So now that we're here, look at this. We have 27 miles, just like that. And now what we can do, my party people, is we can go ahead and add this distance and this distance together. And once we do that, 25 miles plus 27 miles, that's going to give us 52 miles. And that is the total distance traveled by this bike. We are all good. The correct answer here is answer choice A.